Hello learners. Do you know that polynomials are used in everyday life for the purposes of modeling various buildings and objects, used in industries, in construction, and even in marketing, finance, stocks, etc. So what are we waiting for? Let's decode this chapter. Before diving into the chapter, can anyone tell what exactly are algebraic expressions? Do you remember anything about them? Let me help you to remember. An algebraic expression is an expression made up of variables and constants along with mathematical operators. It's a sum of terms which are considered to be the building blocks of expressions. But what exactly are terms? They are the product of variables and constants. It might also be an algebraic expression in itself. Let's understand this with the help of few examples. Examples which are given here, just look at them. Number 3, it's a constant. 2x, which is a product of constant of 2 and a variable x. 4xy, which is a product of constant 4 and variables x and y. 5x square y, which is a product of 5, x and y. But x comes here twice. The constant in each of the given terms is referred to as a coefficient. Let's take another example of an algebraic expression, that is 3x square y plus 4xy plus 5x plus 6, to understand the concept once more. Now here is the sum of 4 terms that is given. And what are those 4 terms? It's 3x square y, 4xy, 5x and 6. An algebraic expression can have any number of terms. The coefficient in each term can be any real number. There can be any numbers of variables in an algebraic expression. The exponent on the variables, however, must be rational numbers. Now tell me, how is a polynomial different from an algebraic expression? In an algebraic expression, there are rational exponents. However, a polynomial is an algebraic expression in which the exponent on any variable is a whole number. An example of a polynomial is 5x cubed plus 3x plus 1. It's also an algebraic expression. Whereas, let's take another example. Is this a polynomial? No, it's an algebraic expression, but not a polynomial. Because the exponent on x is what? Half, which is not a whole number. So it's not a polynomial, but it's an algebraic expression. Now let's understand the concept of degree of a polynomial. Imagine any polynomial in one variable. The highest exponent on the variable in that polynomial is what is known as the degree of the polynomial. Let's take an example to get this concept clear. The degree of the polynomial x square plus 2x plus 3 is 2, as the highest power of x in the given expression is what? X square. So the degree is going to be what? 2. What are the various types of polynomials? Can anyone tell me? Polynomials can be classified on the basis of the number of terms that they have and the degree of the polynomial. Now, if I split them on the basis of number of terms first, let's understand the types of polynomials based on the number of terms first. They are of 3 kinds: monomials, binomials and trinomials. The first one is a polynomial which just has one term. For example, 2x, 6x square, 9xy, etc. Whereas the binomial is a polynomial which has 2 terms. For example, 4x square plus x, 5x plus 4, etc. And lastly, the trinomial, or the last one, is a polynomial with 3 terms. That is x square plus 3x plus 4. Now the types of polynomials that is based on the degree are of these 3 kinds. We have a linear polynomial, a quadratic polynomial and a cubic polynomial, which we are going to study as of now. A linear polynomial is a polynomial whose degree is 1. For example, 2x plus 1 is a linear polynomial, whereas a quadratic polynomial is a polynomial of degree 2. For example, 3x squared plus 8x plus 5 is what? It's a quadratic polynomial. And lastly, what are cubic polynomials? They are the polynomials that has a degree 3 in it. For example, 2x cubed plus 5x squared plus 9x plus 15 is a cubic polynomial. Now, let's decode how to graphically represent the polynomials. And trust me, it's going to be very interesting. We know that any equation can be represented as a graph on the Cartesian plane, where each point of the graph represents what? The x and y coordinates of the point that satisfies the equation. An equation can be seen as a constraint placed on the x and y coordinates of a point, and any point that satisfies that constraints will lie on that particular curve. For example, let's see a equation y equals to x. So it's going to be a straight line, right? On a graph, it will be a straight line that joins all the points which have their x coordinate equal to the y coordinate. For example, 1, 1, 2, 2, 3, 3, and even 0, 0. Also, in the negation of everything, that is negative 1, negative 1, negative 2, negative 2. So, all these points satisfy the equation y equals to x. Therefore, I plot all these points and join them to get this curve. And this is how it's going to look on the Cartesian plane. Let's see the geometrical representation of a linear polynomial that looks exactly like this. The graph of a linear polynomial is also a straight line. It cuts the x-axis at exactly one point. So it's going to cut the x-axis at exactly one point. In the further lecture, you're going to see that this is termed as the root of a polynomial. Do not worry if you do not know what root is. Let's just understand this in further lectures. Now let's understand the geometric representation of quadratic polynomial. The graph of a quadratic polynomial looks like a parabola, as you can see here. It looks like a U that either open upwards or downwards depending on the value of a in what? Ax square plus bx plus c. If a is positive, then the parabola open upwards, and if a is negative, then the parabola is going to open downwards. It can cut the x-axis at 0, 1 or 2 points. Now here in the curve, you can see that this graph actually represents a quadratic polynomial ax square plus bx plus c. And this polynomial has a greater than 0. That is why this curve is actually opening upwards, as I explained earlier. Whereas graph of the polynomial when a is less than 0 is going to be how? It's going to be like this. So this is going to be a curve when a is actually less than 0. But let's also see one more curve. Here a is greater than 0. But this curve is touching the x-axis at only one point, that is 3, 0. So these are the types of quadratic polynomials which you will see. The one that cuts the x-axis at 2 points, one that cuts at a single point, and another one which is not cutting the x-axis at any point. And obviously, the parabola can open upwards or downwards depending upon the sign of a, whether a is greater than 0 or whether a is less than 0. So let's move forward and let's understand the graph of polynomial x to the power n. When n is what? N is actually a whole number. So as n is going to increase, the graph becomes steeper or draws closer to the y-axis. If n is odd, the graph lies in the first and the third quadrants. If it's even, then the graph lies in the first and the second quadrant. So what exactly is the meaning of this? They are saying that if n is going to be even, then the graph is going to lie in your first and second quadrant like this curve, that is y equal to x square. It's this curve. Alright. Whereas they are saying that the graph is actually going to lie in the first and third quadrant if it's an odd number. And what is an odd number? N. If n is any odd number, suppose 3, and it is actually y equals to x to the power 3, then the curve is going to be represented by the quadrants 1 and 3. Suppose this is the curve that they are talking about, and this green one is the curve that I stated earlier. So the red one could be taken as x to the power 3 and the green one is actually x to the power 7. And you can see both of them have what? Exponents as odd numbers. So that is why these graphs are looking like this. So let's recap what all we did before ending with the discussion. Firstly, we studied about uses of polynomials. Then we studied the algebraic expressions. And lastly, we went to polynomials. We studied what is degree of a polynomial, the types of polynomial, and geometric representation of polynomial. So we have reached the end of our discussion. Hope you found that helpful. Now you can visit EduRev to attempt the respective tests so as to check your understanding of the topic. Stay tuned for more amazing videos. Thank you.